Yes. So, hi. So, my name is Sadiqa Watson, and I'm multitasking, admitting people in from the waiting room and talking at the same time. I guess I could disable that waiting room, but yeah. My name is Sadiqa, and I'm the organizer of R-Ladies Dallas, that's in Texas, within the United States. And I know that we tend to have people now that we're in these pandemic times joining us from all over the world. We've had people joining from India, from Peru, from Portugal, from Cameroon, different parts of, just different parts of the world. So yeah, if you wouldn't mind in the chat, could you just kind of type in the location that you're joining us from? So if you're in the United States, maybe your city. If you're outside of the United States, maybe the country that you're joining us from. So we got, let's see, Seattle, St. Louis, Ohio. No city, it's all the same here. That's funny. Arkansas, another Arkansas person, we're living in Dallas. Special welcome from Dallas. Chicago, I used to live in Chicago. I love Chicago, just not in the wintertime. Turkey, hello to Dallas, to one of our members. Iowa, India, one of our speakers is joining us from India. Oop, I gave it away. Sorry. I gave the surprise away. Garland, Texas, not too far from where I am. Lisbon, Portugal. Irving, Texas. Mexico. Austin, Tyler, Texas. Iran. Wow. This is just, it always blows me away every single time that we have so many people. I know there's so many different competing time zones, but you decided to be here live and, not worry about a recording, but to be here live so that you could interact with the speakers. That is so awesome. And I'm definitely appreciating you and your time for being here. Allen, Texas, yeah, local as well. So welcome. So we in R-Ladies, of course, our mission is to make sure that the programming language, data science, tech career opportunities are all available to women or non-binary persons who are just interested in using the R programming language. And that spans to any of the different levels. So if you're a beginner, maybe you just downloaded our studio today and now you're just looking for like-minded people because your mind was blown and you thought, wow, this is amazing. Where has it been all my life? To people who have used R for many years and have become proficient in it, such as myself and some of our speakers, and both of our speakers, and everybody in between. So we want this to be a welcoming space to everyone. So yeah, we definitely try to have content, as you can see from the topics that we selected, that are some beginner level and some are advanced level. So we hope that you can learn something from all of the different presentations that we've got lined up. So before we jump into our speakers, I'll share my screen and I'll just kind of give you an idea of what we've got lined up. So right now we only have one speaker, I think, in the pipeline. So of course you're here for the two presentations that we'll have today. And then we also have another presentation coming up soon from Amber Thomas. She'll talk about data storytelling. And you might remember I said this last time that when I asked Amber, do you do any cool stuff with R? She said, not really. I use it for data cleaning, but I can talk about data storytelling all day. That's kind of my bread and butter. So I think that's a really compelling topic. I think people who use any programming language could use some help with getting some ideas to tell stories with data. So I think that will be a really interesting one. We are, as you can see, that's our last speaker that we have lined up so far. So if you're interested in being a speaker for a future session, either as a primary speaker, where maybe you have about at least 30 minutes maybe of content, and maybe you have some slides, you might have some demos, or maybe you want to make it hands-on or something like that. Then you might want to let me know so that I can put you on the calendar to give a presentation. I can definitely work with you if you kind of have an idea and you want to figure out, okay, how can I turn this into something that I can present? We can definitely do that. Another option is for you to be a lightning speaker. And you'll see an example of what that will look like in a few, because we do have a lightning speaker tonight. But that will be a shorter presentation. It could be as short as 5 minutes. It could be maybe 15 to 20 minutes. You can have slides or don't have slides. It's really just a matter of you letting us know, hey, I found this cool package. in R that I find useful in my work, and I think other people should know about it. Or I'm doing this really cool thing with R, and I just want to share. And so that could be you just showing us your code or your output in R Studio or something like that. So yeah, if you're interested in being a primary or lightning speaker, then please reach out to me and let me know. Jessica Rinks asked, I missed the last session. Is the recording available somewhere? I do have the recording. I don't think I posted it yet. I think that's probably what's going on. So I'll double check that after. But yeah, I've been recording the last few sessions and have made those available to YouTube, and I've been posting them on Twitter and in Meetup. So yeah, if I haven't posted it yet, then I'll make sure that that's available soon. Any comments or questions or anything before we get started? I think that's it. I'm going to go ahead and introduce our first speaker. What's my Twitter? Oh, my Twitter. So my name is Sadiqa Watson. But yeah, you can just use the R-Ladies Dallas Twitter, and I'll go ahead and type it into the chat. It's just at R-Ladies Dallas. Let's see, at R-Ladies. I think it might be at Dallas R-Ladies, but want to mess this up, but if that's not right, I'll check it after I introduce the speaker just to make sure it's the right one. But that's probably the best way to reach me is through the R-Ladies Dallas Twitter. Great question. Yeah, I'm tickled that you even asked the question. I'm really looking forward to seeing some of the other ideas that you all have. Okay, so we'll have more. Yep, Dallas R-Ladies, thank you. All right, so without further ado, I will stop sharing my screen and I will introduce our speaker, our lightning speaker. So I kind of gave it away earlier, but Praveena Matthews is joining us from India. She is the founder of R-Ladies Chennai in India. So I'm just tickled that you even thought that that you would like to join us. I'm not sure what time it is there, but I'm just really happy to see that this is our first international speaker in our speaker series. So I'm pretty tickled. Praveena teaches R for graduatetutor.com, and Praveena will be talking to us about classification and regression trees. So with that, I'm going to stop my video and turn it over to Praveena.
Hi, everybody. Thank you, Sadiqa. Hi, good evening, everyone. Nice to have you all here. I think one of the few advantages or the few plus points. Am I audible to everybody? Can you hear me?
Yes, we hear you.
Okay, great. One of the few plus points I can think of, it's only, I wouldn't say plus point, but one of the brighter sides of this entire pandemic situation is that we are able to, everything's online now, so we are able to connect with people from so many different countries, as we see. So let's go ahead. Thank you, Sadiqa, for having me here today. I do R-Ladies Chennai here in Chennai, a city in South India. And I want to talk quickly about classification and regression trees today. Just go into quickly how you can deal with two data sets and how you can do classification and regression in this live talk. I will share the slides with Sadiqa and the code with Sadiqa after this session, right? And so I'm sure she'll send it to all the attendees. Okay, starting now. Now, classification trees. It's just how before we talk about classification trees, just quickly about machine learning. What is machine learning? We use previous data or observation or data points to analyze patterns in data. We do this to classify new unknown data. So our basic concept is that we can do this with minimum human intervention. So you're trying to just analyze data to predict future data or future unknown data. So for example, if I were asked you if a borrower will default on data, then you would say that yes.
Praveena, are you sharing slides? Because we don't see anything yet.
No, I'm going to go into my now.
Okay. I mean, not your slides. I'm sorry. You don't see anything.
Oh, I haven't shared my screen yet. I'm just going to start my code now.
Okay, perfect.
Okay. So if you are predicting the number of cars that will be sold all over India next year, yes, that will be machine learning, because you're looking at, for example, the number of cars that were sold the previous year, and different factors to predict the number that will be sold the next year. If we were just selecting the tallest build in a class, no, that is not machine learning. It is looking at your data. So these are some applications of machine learning, like logistics, delivery apps, recognizing photos, fraud detection, etc. Now we come to tree-based models, where you have in the structure of the decision tree, you have your main parts would be a root node, the terminal nodes, which you call the leaves, and the branch. So what you do here is you come to a certain node, you see whether that your data satisfies a certain condition, and then you move on to the next node. So the advantages of tree-based models are that they're easy to interpret, they're accurate, they can handle all kinds of inputs, they can handle missing data, and you can use it on large data sets. And you can use this to identify the most significant variables. We're going to start with classification trees now, sharing my screen.
We lost your audio, Praveena. Are you still there? Oh, there you are.
Yes. So this is my, I have this data called credit one, and just looking at it, I'm going to, so my screen. And just looking at that data, it is just whether a person is going to default or not on his loan based on other factors like the duration of the loan. What is the credit history of that person? What is the purpose of that loan? Can you see my explicit?
We're having some issues with the audio. Okay, you're back.
Okay. The purpose of the loan amount, and all these factors. Okay. So we're going to go look at whether we can predict the default values correctly from all these columns. So I'm going to look at the structure of my data with str now, and this is what I get to. So these are all the factors here, and you can see there's default here, which is a character. Actually, it's not factor. So we're going to look at the structure of default now. I want to see what kind of variable that is, and it says it is a var factor with 2 levels. So I had actually changed it here. So I convert this default from here into a factor with the as factor function, and that is how I get that it's been changed into a factor. And then looking at it now, it's a factor with 2 levels. Yes, no, that's it. No, that's here. Okay, now we're going to do a modeling here. But first, we have to install the R-Part package, and then we do a model here just to show you an example. You run this model, and you say method is class, because the classification is what we want. We want the default values to be a factor, either yes or no. To display the results, we can use R-Part plot package. So we do library R-Part plot, and these are all of your values. This is what you get when you. This is the plot of. You can see. So if the credit history is these values, critical, good, or poor, it goes into this node. Otherwise, to the other node. And so you go on at each node. You check the conditions till you finally reach a decision whether the person is going to default or not. Now I've just done this for the entire data set now, but that's not how we should do. You should always have a training data set and a test data set. Now, why do you have a training and a test data set? That is to check whether the model that you've got works on the model that you've got on a certain subset of data works on unseen data. So for that, you have to create a training and a test data set. First, we look at how many rows there are. We do it with the number of rows here. And then we round that value, we get 80% of the data set. That is the number of rows that we are going to use for your training data set. Now, I'm going to take an 80% random sample here to create a vector of indices for your training set and your test data set. How I would do that is I would first do my set C. So every time I get the same result, the reproducible result, and then I do the train indices. I sample the numbers from 1 to n, and then I take A values out of that. A is 80% of n, and then I just get a credit 1 train and a credit 1 test. I'm splitting my data here into two training and a test data set. Now I'm going to create a model here using only the training data. As you can see here, I'm going to use only our part we've done already. Now I'm going to just do it only on my train data set. Now, what happens when I look at the model output? The model output now, this is the output of my model. What this shows is that initially you had 800 observations, and this is a node number. There's the split. There's a number of observations here, and then you have you can see how the data is being diverted to different nodes here, depending on the values of these variables here. So you can see which is the most important variable. It is the credit history of the person. So that is what it splits on first, and we are going to look at that in a moment. So this is your model. Now, how do you do? Now we have created this model using, remember, we have used the training data. Now you're repeatedly splitting your variables here, your predictive variables like duration, amount, and age. And you start with a variable here, credit history, that has the highest association with your Y, or with the value of with the default variable. The default is whether the person is going to default or not. So your credit history is what has the highest association with your response variable. So the outcomes are here at the bottom. This is where you say whether the person is default or not. And so this is your decision tree. So at each node you have a single variable and a cutoff on that variable. And these are your outcomes used to make predictions. Now, how do you compute the predicted classes using this? So for that, I will do class prediction. This is the model you have just created, or the tree that you have just created, your model. And you're giving it new data now. It's not training data anymore. It's a test data. Again, type as class because it's a classification. You're going to say default, yes or no. And this is how you create your class prediction. So I'm going to run that now and get predictions here for my test data, not the training data. And then once that is done, I'm going to calculate a confusion matrix. To look at a confusion matrix, I need to install a package called Caret. That is what I do, and then I do library Caret here. So class prediction. See, class prediction, it's a factor with two levels, yes and no, because those are the values that you have predicted for your test data, not your training data. And then the confusion matrix is how we find out how right our predictions are. So doing that, going ahead and doing that, library Caret, you run your library Caret first, and then you do your confusion matrix. Oh, sorry. Yeah, it's just going back here to default, and then I look at default here. Yes, now that is a value with two levels, S factor, and then I run the model. Okay, so print model, and again I do a confusion matrix here. Here, so just a second. Just give me a moment here. Okay, so this is your class prediction here. And then looking at class prediction here, you can see it is a factor. It's a factor with again with just levels yes and no. Now, how do I do the confusion matrix for that? This is my confusion matrix for the this is a confusion matrix. You can see the reference is whether it's no and yes, and these are your actual predictions. These are the values from your testing data set, and these are your predictions. And then you have all the sensitivity, specificity, etc. Now, looking at the sensitivity and specificity, you have it. I'll send you what those values are. It's just checking how correct your observations are. I will send you description when I share the code with you. Okay. So now there are two ways in which you can decide how accurate your model is. There is a Gini index, which is actually it is just a measure of the purity. When you say Gini index, you are trying to make sure that your the populations in each node are as pure as possible. That is, when you finally come to a node like this, you want to make sure that all these observations are as similar as possible to each other. So the Gini index is just measuring the purity of that node. When you say the purity of the node, it means how similar are the observations in one node to each other. So we use two indexes here. One is Gini index and the other one is entropy or information gain. So if a region or a node contains data that's mostly from a single class, or it's mostly yes, then you say the Gini index value that is really small, and that is how it should be. So the Gini index and the entropy vary. Now I want to show you two ways in which we can train two kinds of models. The first one is if I were doing a Gini-based model, then I would run this, and this is parameters. So I'm going to split it based on the Gini index. So running that is one model. I could also do an information-based model where I would say, in the parameters list, I would give information like here. There are two ways to do a model here. Two ways. And then in this line, I'm going to go back to my test set, and I'm going to generate a prediction on the test set using the Gini model. So for that, my object is this, which I just created here, the Gini model. Or when I say Gini model, I mean it's a Gini-based model. That is, it is based on keeping the Gini index as small as possible, and that is what we specify here in this parameter. The data, again, as earlier, is spread one test, not train. Type is classification. This is just like earlier, just like we did all of these models. The only thing is that you are now changing your model to the Gini model, like we do here, and then it's a new data and a type of class. You can also generate predictions on the validation set using an information model, which we take from here. Again, in the parameters list, you have information. So that is here. And then how do you compare your predictions from these two models? For that, I would do library metrics, that's to get the classification table. And then to compare classification error, I just use the CE function, which is this is your actual value, predict as default, and this is your predicted value. So let's look at what are the errors. Is 0.28 and this is 0.8, pretty much the same value. So this is how you would do two kinds of you would look at two kinds of indices to measure the purity of your set. So classification error is just a fraction of the incorrectly classified observation. It's a fraction of incorrectly classified observation. So when you compare the classification error of these two models using this function, and you can see that both are the same in this case. And now we can move on to regression trees. So I'm going to use California housing data set from Kaggle. It's from Kaggle. I'm going to first read it in here. We'll send you this file as well. I mean, I will send this to Stick out if not. So And then I'm just going to take the first 2,000 observations. Looking at the California housing data set here, you can see these are all the values. These are housing values depending on location, and then the age, number of rooms, bedrooms, population, etc. Ocean proximity is another. I'm just going to take the first 2,000 rows. It's a really big data set, so we just need this to show the observation. And then I'm now going to just look at a summary, just to quickly look at what all the values are. Another function that I found really useful is from the Dippler package. So you would, I'm assuming you're familiar with Dippler. So I would run library Dippler, and then I would just do a glimpse of my housing. So, or housing 0. So let's do library Dippler here, because I've not used it in the session so far. And then glimpse of housing. All right, so you get to see what those values are. And then we're going to set, what we're going to do here is we're going to use, we're going to have 3 kinds of sets, three sets, a validation, a test chain, and validation set. Sarika, how much more time do I have? I think I've exceeded my time.
Yeah, we could wrap in about 5 more minutes.
Okay, great. So, sorry, Pavitra.
Absolutely no problem. This is really interesting. Please.
Okay. I'll do that, but I'll wrap up. So, we're going to now split the data into 3 sets. We are going to do it in a different way. I'm going to sample it based on the size. The size is actually the number of rows of housing, and these are my probabilities. Now, what it means is that I'm going to draw a sample from 1:3 with replacement, because here you have replace is true. And I want about 70% of my sample to be 1 and the remaining 30% to be between between 2 and 3. And then I'm going to subset my housing based on these values, on the sample that was just drawn. So indices with a value 1 will be in housing train, with a value 2 will be in housing is a validation test, and the 3 will be in your rate test. Okay. So I have these data sets now. Let's run that quickly. I don't know how familiar you all are with the Dippler package, but it's really, really interesting. Lots of lovely functions. I've just used glimpse from that, but there's lots. Okay, so I'm going to set the seed, and then your assignment is here. And then I am going to run these lines of code to get 3 different data sets. And then I'm going to train my model here. So median house value, depending on data is now actually housing train, and then method is another because it's regression. And then looking at the model output here, yes, we can see there are so many observations, and the median income is the most important variable here. Okay? So that's how you print the output. And you can plot it here with rpart-plot. We've already done library rpart-plot. Now, what are these values? Type is 0, extra 0, and all of these. So type is 0 means you're writing a split label at each split, and then you have a node label at each leaf. And then extra is equal to 0. There's you don't write any extra information. Yes, no equals 2 means that if I give yes, no equals 2, like here, you are writing a yes and no at all splits, like yes and no. So these are just different parameters that you can keep changing to change the appearance of the plot. Now what I'm going to do is, like we did earlier, I'm going to take my housing test value, and then I'm going to predict my values here on housing test using the same method. And then you can find the errors there where you have actually predicted, and these are your errors. Now, how can you plot the complexity parameter here? What is the complexity parameter? I'm going to go a little faster now. A complexity parameter is just you don't want your tree to have too many splits. That is, if you have a very high complexity parameter, your tree is going to be smaller, because a tree that is really big, is not, if it's too complex, it's not going to add anything. It's not going to help you. And so how you, your basic rule is that if the split is not going to improve the quality of your tree or reduce your errors, you're not really going to split. So you want to find a certain optimal value of the complexity parameter. So they're going to test and see which complexity parameter is best for you. So for that, you can plot the CP table here. What this shows is that there's a relative error here, and then you can see size of tree and its complexity parameter. You can see after a certain point, your error is not really decreasing. So you need to decide when to stop your tree. So what I'm going to do here is, since I've already plotted the tree, I'm going to see in the CP table here. So this is your output when you do plot CP model tree. You can see after a certain point, after your tree increases in size beyond a point, the error is not going to go down. So we are going to now just do print the table here, and looking at the table here, see, you can see the values. So the relative error is not going to go down. Number of splits is 8, and this you really don't go all the way. So now we're going to see where it's minimum in the table. I'm going to see where your error is minimum. You're going to get that index here, and then we're going to just find the optimal CP from here. So looking at the optimal CP now, it is actually 0.01, which is here in your 0.01 is here in your table. So now we're going to plot the model with that. We're going to make a model with that CP, that complexity parameter, pruning your tree to get only that complexity parameter, and then you plot your optimized tree here. Okay, R-bar plot. This is your optimal tree, and then yeah. So yeah, I think that's today. We have yeah, this is the optimized model for the complexity parameter. There's more, but I really want to be able to teach that today. So thank you, Sadika. I will be sharing the slides with Sadika after this. Yeah, this is just the complexity parameter. So yeah, it's
okay. Yeah, thank you, Praveena. Yeah, that was really interesting.
Sorry, more time. Sorry, Pavitra.
No, you're good. You're good. Actually, I was it just kind of underscores the point, because when I was just kind of talking about lightning talks and what they're about, and why we want to have them. So like classification and regression trees, the R-part plot, all those are things that I've used before, but I definitely learned some things in your presentation that I hadn't seen before. Like I hadn't used this particular pruning function, and like I hadn't used that metrics package, and so I learned different types of things. So I think everybody at every level can learn something from anyone. So yeah, I definitely appreciate you taking time to put this together. And I'm sure, I don't know, we can maybe take a question or two. Does anyone have a question for the presenter?
I actually have a question, Praveena. Is it okay, Sadika?
Yeah, go ahead.
I was wondering, Praveena, how does it establish the most prominent variable? So you know how it took the medium income as being the highest for this particular data set, and the other one, I forget what it was, but has it already done some sort of a regression where it has looked at the weight of that particular coefficient, or like how does it establish which is the most relevant variable in your data set?
Yeah, the tree does that. It looks at on which variable, if you split, will you get your, like for example, if I were looking at the tree is sitting on the variable, which gives you the maximum. For example, if you're splitting your entire data set in 2 observations based on 1 value, you would want the observation, let's call them buckets, in 2 buckets based on 1 variable. You would want all the observations in 1 bucket to be as similar as possible to each other, and all the observations in the 2 buckets to be as dissimilar as possible from each other. You're just going to look at what gives you the maximum information gain. On which variable, if you split, will you get the maximum information out of this tree? Or on which variable, if you split, will all the observations on all the nodes or all the buckets or the two buckets that you get be as similar as possible to each other. So it's just a process where you are constantly trying to make your tree better, and you also want to go in for as simple a tree as possible in the end, because you can keep splitting it into, if you have 100 observations, you can have 100 nodes in the end, but that doesn't really give you any information. So that's where the complexity parameter comes in, where you try to say you don't go beyond a certain point, you don't prune beyond a certain point, you don't grow your tree beyond a certain point.
Got it. Thank you.
Thank you. Yeah, so it looks like we've got one person in the chat asking for you to give a full presentation on this at some point. I know Pavitra was asking as well, if you could give a full one, and I'll give a third vote for that. So we would love to have you back in the future if you'd like to give a full presentation on this, so you can have more time to explain everything. Yeah, this was fantastic. Yeah, thank you for being available, like I said, and putting this together. And yeah, and I know we all learned a lot, and now we're excited to learn more. So thank you very much, Praveena.
Thank you. I'll send you the notes, Chris.
Yeah, and I will add one more thing that I use these approaches quite a bit in there's this field called not field, but I guess this initiative called machine learning interpretability. I don't know if you're familiar with that, but it's where you're trying to understand, okay, there's this black box model. It's really complicated. What did it learn? Like, what are the different kinds of patterns that it picked up on? And so you can use a tree, like this to take a model, any kind of model. It could be a neural network, it could be a gradient boosted machine or whatever, and then come up with some explanations, kind of like this, like, people who went along one path of the tree, tended to have high probability of default versus this other path, they're likely to have low probability. That's what the tree has learned. So that might be a good topic to bring up in the future. Maybe I could give a talk on that or bring it up. But yeah, okay, well, cool stuff. Thank you. And we'll transition to our other speaker. So Pavitra is a member of R-Ladies Dallas. So special shout out to R-Ladies Dallas and our members. And she's definitely been involved in some of the different initiatives we've had, and also have been, she also gave a presentation before, and has also given lots of great suggestions on formatting of this event, of this meetup. So yeah, definitely happy to have her here. So her, let me just share a few items from her bio. So she's a data engineer at Converging Health. She's also a bench trained PhD scientist, and she might say a little bit about her background if you like. She uses enterprise tools in her day job, but please don't hold that against her. And she's all about open source. That's where her heart is. So yeah, she has her Twitter information and all kinds of other stuff available on the meetup page. And with that, I will turn that over to Pavitra.
Hey guys, I'm not going to waste any more time introducing myself, but there's my Twitter account. I'm very active. I love posting and reposting all kinds of cool stuff. Sarika, can you hear me?
Yes, I hear you just fine.
Okay, cool. All right. So I'm not really doing a live coding, but I'm kind of going to switch between my presentation and actually showing you some of the stuff in my RStudio. I'll just quickly start by saying that I use Sharingan Extra. So the cool thing about Sharingan Extra, for those who are unaware, is that it allows you to, you can actually create tabs on your presentation. So let's just get started and see what a GT object is, and then we'll switch back to the RStudio session. So this is a pseudo code for what a GT function classically looks like. It's got your data set, and it has these two like weird sounding things, and we'll get into that in just a bit. Row name underscore call, group name underscore call, and row names to stub. So by the time you're done with the first 5 minutes, you should know what these are. And then you can also actually create groups. And then that way, sort of like, you don't necessarily have to go through dplyr. You can, within GT, you can actually do your own grouping and break things up according to groups. So the cool thing about sharing an extra is that you can create these tabs. So if you don't want to have everything crowding up one screen, you can create these little things that you can tab through. So we're going to be using a data set from GT called Exable, and it's kind of it's a medium-sized data set. But the nice thing about it is that it has columns of all different data types. So it's a really great way to validate different aspects of your testing. So we're going to just take a small sample of that, and we're going to pipe it into GT. So the cool thing about GT is like everything else in the tidyverse, everything is pipeable, right? So you can pipe it to a GT function and then pipe it downwards once you have a GT object. So when you do that, you get back something that looks like this. So there are some NAs, of course, but then you can see that it has these columns. So some of them are character, factor, etc. But it has a row name per row, and there are different groupers. So this becomes important to understand what a row name underscore call and a group name underscore call is. So you can see that there are groups that have been assigned to different rows, and you have so they're probably group A and group B. And they also have row names. So this is, I don't know if you've seen the empty cars data set, but it has row names. And so it's kind of a nice way to actually have a name associated per row. So, and this will kind of become important once you see what we're actually doing with these two functions, these two parameters here. So row name underscore call and group name underscore call. So if you recall, our pseudocode for the GT function had these two variables here. So we have row name underscore call and group name underscore call. So just going to go and see how what that exactly does for us. So I'm going to use my row name underscore call as row and my group name underscore call as group. And if you remember in the prior table, our row name column was called row and group. So like, I mean, obviously, like it's pretty easy to see where these two names are coming from. So when I run that, what happens is that GT nicely, and mind you, this is like literally with like 3 lines of code, right? All we've done is taken the data set, piped it into GT, and then we have passed along these different parameters here. And we already have something that's starting to look pretty good. We have our row name here, right? And we've also grouped them by the corresponding group that they belong to. Now, because this is taking a sample each time of 4 rows, you won't see the exact same thing each time when you run it. But suffice to say that group A has been taken up as a group by, and it has its own rows, and there's some sort of an ordering that's going on there. And group B has its own rows, and there's some sort of an inherent ordering that it's doing. So once you do that, if you want to have, so I don't know, I'm going to quickly pull up a little info. It's sort of a little, yeah, it's a small infographic of what the parts of a GT table are. And I just want to get into that so that I can explain to you what a stub is. So I don't know if you recall, but stub is that part of your table where it doesn't have a label, and it's just sort of sitting there, and you can label it if you choose to, or you can choose not to, but this area is called the stub. So I think the others are kind of self-explanatory. We have the title, the subtitle. The spanner column is something that spans multiple columns, and these are the labels. And then the row group label is what we just saw, where we saw row 1 or row 2. And then we had the group labels, which we saw when we broke them up according to groups. Cell would be each individual cell in your table. And you have the footnotes and the source notes. So what I'm talking about right now is this particular area here called the stub, which is right at that little edge on the left. And you can either choose not to label it, or you can choose to label it if you want. So if I say that I want my row names to actually belong to that stub column, and I set that to true, and I run that, I will, so this is a different data set. This is, I think it's, yeah, so this is empty cars. And we can quickly go into our studio and take a look at what empty cars actually has. Let me just see where I can pull it up here. Pseudo code, oh, I think I already ran some of this. I'm just gonna bring up empty cars. Okay, so row and column. Okay, so let's just take a quick look at what empty cars has before we actually see what that little thing after that brings up. So if you just run empty cars, you see that we have, oh wait, did I even run this? Oh, sorry. Okay, so if I just run empty cars, what I see here is that I have, it returns 4 rows because I asked for 4 rows. And I can see that there's all these columns like miles per gallon, the number of cylinders, etc. But there is this column here at the very beginning, and it's actually the name of the row, like or what you call the row name. So if I want to assign this to the stub column that we saw earlier here, and we want it just to belong to that, you would go into GT and you would basically say that you want your row names to stub, and you would set that to true. And what it would do is, there's no label here because you didn't ask for it to be labeled, but however, each one of your rows would be labeled. So it's kind of a neat way of using what is inherently already present in your data set and just like giving it like some sort of character here, I suppose. So the other thing here is that you can, this is just getting back into the same thing. I just wanted to give you a few more, just a little bit of a flavor for what you could do with this. Again, we see the group by, we see this, but this is with the, this has been, instead of using the group name call. So if you recall, we have the group name underscore call. You can either choose to do it that way, or you can use the dplyr function. So it's the nice thing about GT is that it plays really well with the rest of the tidyverse verbs. So like dplyr, you can do all of your pre-processing in dplyr and then pipe it into GT and not have to necessarily use the parameters that GT has. I mean, you could do that, or you can make use of what GT has, which we will see is actually pretty considerable and leads to some really sophisticated looking tables by the time you're done with it. So now it's already starting to kind of look good, right? Like you can see that, I mean, of course, the formatting is off and they're like all over the place, but you know, there is some structure to this. It has sized your column without you having to specifically set the pixel width or whatever, like it sized it based on whatever data was in that column. So with very few lines, you actually accomplished like some sort of structure. You know what I mean? So then let's go ahead and see what else we can do. Preview is nothing but just taking a quick snapshot of what your data set has. So it's sort of like what Praveena said, like you can do a glimpse, or a structure is not structure as much as glimpse, or if you've heard of the skimmer package, which is personally one of my favorite packages, it gives you like just a little bit of a glimpse of what your data has. So if this is my pseudocode, so this is like all the things that you can pass to it, how many of the top rows you want to see, how many of the bottom rows, and if you actually want to include row numbers, which is by default set to true. So I have selected example here again. I've selected a small snippet of the columns, and I ask for a preview. So here you can see that it gives me the row numbers and the rows that are missing, in which case, in this case, it's 6 and 7, and then this is the last row. So it just gives you a quick glimpse of you know, what is in your data set and how you want to present it and things like that. So the other cool thing that GT lets you do is that you can actually save your tables. So there's this function called GT save, and if you save it, there's nothing here for me to show you, but I'm going to show it to you in the RStudio session. This is what the code looks like. I have piped this to my GT where I want to display the row names, which you recall was that first column, and then I want to group them by this particular column, which was group. And then I'm piping it to GT save. This is the name of the HTML, and you can save it as I believe it's ping. I don't think doc is possible yet, or I'm not sure if Rich has already made that change, but I think it's ping and definitely PDF. Yeah, I'm kind of drawing a blank, but the last I heard, doc was not yet possible. So let's just jump over to RStudio and just take a quick look at what happened. So I'm going to go into my files here. So I have not opened the correct project, so that's not very good. But anyway, I am in the root of where I'm running this RMD from. So if I wanted to save this instance of my table, so let's say I want to send it off to, like, I want to present it somewhere, or I want to include it somewhere, what I would do is I would preview it, I would see that it looked good, and then I would come in here and I would actually run this little thing here, the same code snippet that you saw. And when I run this, what you'll find here is, and it's going to create a file here called tab_1_inline. It's not here right now, but when I run it, it will create that file for me here. So it should have, let's see, did it not? Wait a minute. Maybe it didn't create it. R-Ladies Dallas. Well, it should have created it. One sec. Files, R-Ladies, desktop. Okay. All right, let's hope it's here. It has not created it, strangely enough. I don't know why. GTHTML. Not sure. Well, it should have. Wait a minute. Did it time out? Oh, you know what? I wonder if it timed out actually. It's scheduled to run later. Not sure what that is about. For some reason, it seems to. I have a feeling that my computer probably is timing this thing out for some strange reason. I don't know. It could be a network issue. But suffice to say, all things working, it actually works remarkably well. I'm going to try this another way. Let's see if that works. It somehow. This is weird. Don't run. Okay, well, let's try it now.
Try if you click your mouse over in the left column where the numbers are, if you right click there, click reload.
Oh, reload it. Oh, that's a good idea. Oh, yeah, maybe that's what it is. Thanks, Sarika. Appreciate it. So let's go back there and hope it saves it for us. Yeah, I didn't want to spend a lot of time because I wanted to get to like the meatier parts. Okay, well, suffice to say it does save it, and it's a really pretty looking presentation, but I'm going to upload this anyway to our Git, and you guys can try this out, okay, because I don't want to spend too much time here. Okay, so we are then going to look at what are the different, what are the, where is my, did it just close my, okay, it appears to have shut down my, okay, well, I'm going to have to net it again. Okay, I'm just going to net my RMD because it closed down my presentation. So, okay, so yeah. So let's go on to, okay, so we're going to move on to the part where we actually change parts of that table. So all of these functions helpfully start with a tab underscore, and then you can change, you can basically see their functionality based on what their titles are. So we're going to look at two of the most, I guess the most widely used ones, the stub head and the spanner. And basically what this is it lets you put a title in that little spot, which I told you about, the left, the one all the way to the left where you could have row names or whatever, and you can specify the label. Very straightforward and simple. We're going to use the row. We're going to use that row column for that. We're going to group them, and then we're going to label that little stub area as row name. Right, so we've called our stub head as row name, and that's what you see here, that now we have a title and it's called row name. We can also combine multiple columns. So let's say you're looking at like, performance efficiency of a car, and you're looking at things like your miles per gallon and, how many, whatever, like, I don't know what goes into looking for how efficient a car is, but if you had to look at performance and you were going to look at the RPMs and the miles per gallons, etc., you could span them under like one header, and then you would just look at that. So then that way they are kind of like all nicely bunched together. So looking at the empty cars data set here, you can see seem to be having some memory issues, but okay, so this is the empty cars data set, and you can see that it has created the spanner kind of a thing here, and you have these 4 columns that we specified here. They come under that header, and so it's a nice way to like tie things which are related together into like one little block. So then we get into tab header and tab source node, and this is kind of important for people who who make tables for like journals and things like that. Your header, of course, there's no guesswork there. You can have a title and you can have a subtitle. So if you went in here, this is your pseudocode for your tab header, and this is your pseudocode for the source node. So a source node actually ties in the entire table together. It's not the same as a footnote. It's actually for the whole table. So if I had data from, say, and I pulled it from the 538 website, I would have a little source node, which I would say all data sourced from the 538 website. So here we are taking a look. This is a little bit more involved, this little example. I kind of wanted to keep that thread going where I had like prior commands like sort of being piped forward, so you could see how nicely you can actually build that little workflow. So this is what we did before. I'm getting a small a snippet of that data. So then we select our columns of interest, we create our stub, our row names, our groupers. We created a little spanner for the performance columns, and now I actually have a header. So I've created a header, and I also have a subtitle. So if you looked at the pseudocode, you can do a title or a subtitle. And then we are going to add a source node, and it's just really tying all the entire table together. So if you look here, you can see that now you have a title and you have a subtitle, and then you have this little thing here at the bottom, which is your source node. So now the cool thing about this is Rich being the author of this wonderful package, has given us the ability to actually add HTML and MD formatting. So what you could do is that when you set up titles or names, you can use formatting characters like MD. I'm going to see if I can find an example. I'm sure I did include. Let me see. Okay, so this is all that we saw. Tab header, source note, performance, and then here you have the footnote. Okay, well, it's probably coming at some point. I don't see it right now. Okay, so that was your source node. So now we're going to look at footnotes, which is pretty important for all the scientists and the others who are actually making tables for, for journals, etc. So it kind of, it starts to get really pretty involved at this point, because it pulls up a few design elements which are going to be used in other instances. And so even though footnote itself is not like terribly complex, it brings in these formatting components which are going to be used like for other things, and this is like your first exposure to that, and so that's why it looks a little bit more complex than footnote really is. So this is your pseudocode for your tab footnote. But you also have something called tab style. Okay, so in addition to the footnote, you can also define the style of how you want a certain cell or a certain part of your table to look like. So the reason I put that here is because it's tied to this particular attribute here called locations. The cool thing about locations is that you can target any part of your table. So if I say I want to explicitly format only my title, if I only want to format my stub, if I only want to format my column spanners or the column labels or the row groupers, and in that I only want to look at the text, the textual component, or I only want to fill that with a color, or I want to have borders, it really starts to like build up on the power that is this package, which is probably my most favorite of all in R, is that it really starts to like get really very powerful at this point. So I have a footnote here. This is relatively straightforward. I've just added a footnote. So your source note is always at a lower level than a footnote. And here you can see that it's added, and you can indicate whether you want letters or you want numbers. But I've preferred to use numerals here. And then here at this point here, it'll tell you what you're actually looking at. Right? And so now here, I wanted to show you a little bit of what you can do with the tab style components. Okay, so you added the footnotes, correct? And you added, you have, actually, let me go back here. So you already have seen here that we have locations. So the reason I say that I included locations here for this footnote is, if you look here, I've only selectively added the footnote to mpg_c and mpg_h. So these are the two mpg columns. So in locations, I can say that, hey, just pick those columns that have labels where the name of the column is this, right? So vars is actually asking not for the label of a column, but the underlying object name, or in other words, this is the name that the tables, the object identifies like components of itself or others. So this is actually the name of that particular column, and you're saying that you want to specifically put your footnote, your superscript to be on those columns. So that's what locations is. And if you recall, that's what we had here under tab style. We could specify locations, but locations is also a big part of your footnote itself, and it forms this thread that goes through a lot of the styling elements here. So let's take a quick look at something else where you can use this tab style and where you can use location. So I have said that, hey, you know what, I want you to add this footnote, do all of this, but I want you to give me a border on one of my columns, and I want that particular column to be on this MPGH. I want to have a border on the left-hand side of MPGH. So if you look at that here, everything else being the same, you can see that it has added a little border here, and this has all come in from your styling element. Everything else is the same. You have, and it's reused that same locations thing, which is used in both your footnote and in your styling. So you will start to realize that tab underscore style and tab underscore options will quickly become your best friends, because it opens up a whole new world of integrating CSS, and like if you're good at CSS, like you can literally like take this baby to, you know, to wherever you want. It's so like you know, upward compatible that you can like, the sky is really the limit. So that's getting into like individual cells, and also how you can leverage tab styles, and how you can leverage the locations to specifically target like areas of that table. Like I said, like these are the cells, and then these would be the spanners, the title. So like you can literally hit like every component of you know, source notes and footnotes we saw as well just now. So it's I will actually include this is one of my favorite bloggers in the R world. His name is Thomas Mock, and if we have time, I was going to quickly go do a real-time walkthrough of a play of his code, where he's trying to replicate this particular table. I think this is from probably 538, because they have a lot of sports stuff. I don't remember. It could be another. But he basically like walks us through how he arrives at that, and he does a remarkably fabulous job. So Thomas Mock is wonderful, and like someone who loves GT and does a lot of sports analytics and everything. So I have provided a link to his blog, but that's only the GT part, but his whole blog is a treat, and he's just really, really good at what he does. Okay, so then this gets into just formatting.
Pavitra, I'm sorry, just
Yeah?
1 second before we go on. Yeah, really, really cool content. We've got quite a few people asking questions in the chat. So I wasn't sure if you wanted to do questions along the way or after.
Yeah. No, that's a good point, Sarika. Thanks a lot. So, okay. Yeah, let's see. Interpretability. Okay, so where you can highlight. Yeah, I love that too. This is all part of Sharangan. I think that's Claire. I think, yeah, so Claire, if you look at my stuff here, I have this, right? So I've used this Sharangan extra. I have hover code line. I've set that to true, and I've set use panel set to true. So if you include that, you can see those little tabulated things. So like if your code chunk is large and you want to also show your plot, like you don't have to like go between two different like slides, you can actually do it on the same slide. And then I like it to like highlight it when I'm there, and I like it to also do that hovering. So yeah, you can like I said, I'm going to upload this, so you can definitely do that. Okay, so is it possible to combine GT with spatial regression packages like SPDEP or SPLM? I will admit I don't know much about spatial stuff, but I'm just wondering like why would you use spatial packages for GT? Like if you wanted to include like a little map kind of a thing, or like why would anyone like have yeah, I'm not just seeing a use case for that, but that's probably because I don't use spatial packages. But if anyone else knows the answer. Okay. Well, how is adding the stubhead label different than if you named a column row name? Does it automatically? Yeah, exactly. So the stubhead label targets that particular spot, which is not accessible otherwise. So that's why you explicitly call it a stubhead label. But if you named that column row name, yeah, it would be the same thing. But not every data set has a column like that, where you actually have a row name. So it's conceivable that you may want to use something in lieu of not having a row name column. You may want to assign another column to that, in which case you can explicitly label your stubhead part as being a stub. Yeah. Okay, so I have to drop off one more. Should I ask whether GT creates a regression output table automatically by packages such as GLM? No, it is, that would be GT summary, right? If I'm not mistaken. Oh, I see. I don't think it's automatic. That's what I can think of right now. I think GT summary is probably more for the for the the statistical and regression based tables, I think, but I could be wrong. Okay, so I think that's that. Let me see. So it's not like Stargazer. Yeah, I don't know what Stargazer is. Okay, so moving along. This is fairly straightforward. You can actually format your data in your tables. So like if you want to, you want to have your dollars and you want to have your percent, scientific notation, etc. You can actually change this to. So I wanted this to be like number columns, and I wanted it to specifically have like decimal points, etc. So I've picked the columns where I want to do that, and everything else is, as you can see, is the same. I have a tab style here where I'm so I don't know if you guys noticed this, but there's something cool here where you can actually set a filter clause. So in the locations, you can basically have locations as just being your cell body, and then specify your columns. But if you wanted to target particularly like some rows that passed some filter criteria, you can actually specify your criteria here, which is really, really cool that you can, do it like selectively. So for example, here, I want to color all the cells where the miles per gallon underscore H is greater than or equal to 20. So I have asked for my styling there to be greater than or equal to 20, and I say that I want you to bold it and I want it to be cyan in color. So see how the columns which have been highlighted, all of them now have a formatting, because that was how I selected my, that's how I piped it into, downstream of that. So it selected those and then it piped them down. And then so the formatting criteria was only applied to those that passed that the filter criteria. So it's a really great way to target specifically or call attention to something. And I know you guys have seen now off late, especially in the FT and others, this whole gradient thing is like a big deal, right? Like everyone is doing it. They have gradient colors for all of their data, and it's and GT is just fabulous for stuff like that. So here, for example, I have used this Palantir, which is a package again, and I have asked for it to use this particular column, this HP RPM, and to give me a palette of colors here. So you can see that it has selectively colored this. So this is like that gradient that we were talking about, where the lighter ones are the ones which are lower in number, and then it kind of like, it goes as it gets higher, the color gradient changes. So what I've done here is that I have selected the column HP RPM, which is what you see here. And I have set this palette here. So the GT has just an amazing selection of palettes that are possible. And we look at that when we quickly walk through Thomas Mock's presentation, because I think that'll really tie these different concepts together. So I'm going to run through this pretty quickly. So this is a way to actually modify your individual columns. So if you want to change, so you saw how we targeted cells, we targeted different components of the table. Here is where you can actually change how you want a certain column to change. So what I've done here is, and this I've done very deliberately, is I've changed the width of columns. So by itself, GT will scale everything according to the data in that particular column. Here, what I have explicitly done is that I have set, and you can't see it here because it has actually terminated it. Let me quickly go into our studio. But here, what I did is I actually set the width that I want for formatting. Yeah, so that's right here. So what I did here is that when you set the column width, so if you really, really want to like change the width of something and you explicitly say what pixels you want that to be, if you don't really know what you're doing, you can like really mess things up. So I'm just going to run the same code here and show you what that table looked like. Yeah, for some insane reason, my R session is not behaving itself. But suffice to say, it's basically what we saw here, where you see how like things have been overlaid on each other. Some of them have like huge gaps because this pixel was like 200 or something like that. So if you're going to mess around with the width and height and padding and all that kind of stuff, like you should really know what you're doing, because GT by itself does a fabulous job of like fitting everything in properly. So that's just something to think about. So you can also add summary rows. So like if you want to summarize like different data points in your data set, you can actually go in and set up. I am having some really bad memory issues right now. Okay, so this is your pseudocode for the summary rows. You can exclude your missing text, or you can assign a default value for that. But here it basically tells you that either you group it within a group. So if you set group to null, then it's going to do it across the entire data set. And it's when you set columns to true, it means that you can either use the columns that you have, you can add additional columns, etc. And you can format you can set this to the formatting that you had assigned to earlier when we looked at that format call underscore format or format underscore number, which I don't recall now what the exact text was. But what this does here is that it will, actually, let me come summary rows. Okay, so I think what has happened here is that you can't actually see the last row here because of the fact that it's, I'm going to hope that this works, but I'm not sure now. Let's see if this does work. You know, I may actually kill this session and restart this. I'm going to quit this session now. And I am restarting our studio because I think something has gone wrong. Okay, so let's hope this one does a little bit better. Yeah, okay, so. What is this? Oh, I killed the session. I need my packages. Library GT. And then do I need anything else? Attempt to use pseudo. Oh, this is my pseudocode. Okay, sorry, I was trying to run the pseudocode, so I did not like that very much. So sorry, what happened is the summary column was terminated in my presentation, so I apologize for that. But what this is doing here is it is, let's see if I can pull up summary. Oh, I'm on the wrong one. Calls width. Yeah, I was on the wrong one, sorry. Code 2, okay. So what this has done is that it is going to create a summary. So this is again the previous data set where we had the groupers and then we had the row names. And I want to create summaries for each of my groups, right? So because I want to create it for each group, I am saying that, hey, I have my groups, they're group A and group B. Create a summary row for each group. So it has created for me two summary rows, one for group A and one for group B. So if you look here, you can see that you have, this is your group A, and it has created a summary row for that particular column, for which you wanted to assign um, the summary statistics for. And this is your group B, and it has done a grouper, a summary for that. And I think I also have one happening at the, did I have? Oh, I also have a grand summary. So in addition to the summary rows, I have also asked for a grand summary. So I have the summary for each group, and then I also have the grand summary, which is the sum of the summary for each of the groups. So that's what you're seeing here. So you can create some, some simple summary statistics there for your, let me check the chat to see if there's any questions there. Thanks for the great presentations. Okay, so GT summaries up there, that's good. Table underscore regress, I don't know what that is. Okay, so I think that's, and it is really fantastic for CSS. So you can actually use all kinds of really funky CSS options here. I will not get into that because I am not very comfortable with CSS. And so I don't want to, I don't want to completely come across sounding like a noob. So, but suffice to say, you can do all kinds of, I took this off of his vignette. So here it's looking at CSS. It says the background color is sky blue. It has changed the padding of each cell, and it has center aligned the text. So it's all like you didn't have to use any of your GT functions for this. You could directly do it in CSS. So that's another cool thing. You can integrate CSS directly into that. It's called this one right here, opt_CSS, and then you can just plug in your CSS text here, and it does all of this. Okay, so I'm since we have 9 minutes, I'm gonna actually not go through like the last part, which is really quite theoretical, and we'll just quickly get into Thomas Mach's thing here. So this is a table that he's trying to replicate. Okay, so the first thing he does is, of course, he goes through all of that.
We could actually go over an extra 10 minutes, maybe, if you feel like you feel really more.
Okay, yeah, but okay. So actually, I would really, if we had that extra time, I would really love to walk us through another amazing blog post where he actually tackles JSON data. So I think that would be really more beneficial. So yeah, I mean, like we could definitely do that. Okay, so let me just quickly tell you guys what he's doing. So he has this data set where he's read the CSV in from, this is his account here, and then he pulls in the CSV, and I think this is, and he's already piped it into GT, right? So like you can see like straight off the bat, it's already looking like decent. Like it's literally the data set. He's done a head just to get the first or the whatever X number of rows, maybe the first 6 or something. Yeah. And then he's piped it into GT, and then you already have a basic table. So here he gets into this conditional formatting, or that gradient formatting. What he wants to do is that for the salary, he wants to have a gradient. And you will see that this palette here is a really, really powerful package. And if you want to see what palette here is all about, all you would do is you would go into your RStudio, go to your console, and if you put that in there, it will pop up like all of your color palettes. And like, believe me when I say that this stuff is just ridiculous how much you have here. I can definitely walk you through all that, but I feel like it's probably not a good usage of any of our time. But feel free to go in and look at the different palettes which are available, because it's huge, and I think you can tie in others. So between the palettes and the fonts, like he's pretty much made it such that you can replicate almost anything that you wish to out there, either a New York Times or a FT or whatever. So here what he's done is that he's used the scales package. So scales is another absolutely mind-blowing package. So it's scale functions, right? So you can actually set like bounds and things like that here. So this is let me see. So I don't know which one would be better, but that's probably more yeah, I shouldn't have done that. But yeah, I don't want, again, I don't want to spend a lot of time because, okay, I don't know, someone upstairs is in a bad situation. Anyway, hopefully the children are still alive. But anyway, so this is the scales package, and you can, and here we've used this GGSCI, which is also another scales related package. And what he's done is that he's now going to set the bounds for this. Okay, so what he's saying is that he wants to use here he's just talking about how the colors are and how you can pass all that. But here, when you want to actually see the color generation, you can either do it yourself, right, where you're like doing it by yourself and passing the lower and higher, and it gives you the gradient based on what the sequence is. Or alternatively, you could just use this, right? If you use that color mapping here, it maps the palette of that for you based on what your base color, whatever that was, whether it's red or white, and it'll give you like a thing between those two boundaries. So it's really pretty. I mean, it's pretty incredible. He just walks into different methods of getting that gradient. Like he talks about, you can hard code your codes here, and that would be just fine as well. Or if you notice, what he's done here is that he's looking at the salary column or the total column here, and he has used the scales package, and he's actually sent it and this is easy enough to do. You can plug these codes into, I forget what the name of that site is, but it will tell you what the color is. And also, if you have a color, it can give you what the code is. So you can do it either way and pretty much like tailor it to whatever you want. So he has two different palettes going on here, one for the salary and one for the total. And if you look at this here, you can, oh, I guess they're both the same here. I thought he had a green and a red going on, but I could be wrong. That was just there, but he actually switches back to, okay, that's interesting. So he's used the same like range, and it's just like going from a light green to a really dark green. Here he's formatting the data. So remember, we talked about how we can format our data like by adding columns or percentages or scientific notation or whatever. So the first part of this all gets into all that color gradient and whatever. And here he actually talks about how he can change the formatting on the salary column. And he wants the number of decimals he wants, and how he wants to like the large numbers he wants to append, like a million or several millions or billions or whatever. And this is the calls align. If you recall, we had talked about how you can move your values to the left or to the right, but you jolly well better know what you're doing, because this is similar to like setting the width or the height, and you can like severely mess up if you don't know. But because these are numeric fields, I guess he wants them all right aligned. So he explicitly asks for it to be right aligned. And he also says which column that he wants that to be. And the borders, we saw that as well, tab underscore border. Cell underscore borders, excuse me. So this is the tab styling element. So remember I told you that the tab underscore style and tab underscore options will quickly become your best friends, because they will let you like target any part of that table. So this is the tab underscore style, and he's specifically targeting the cell borders for the cells belonging to that particular column, which is the total column, and it will create a nice, beautiful partition for him. So, I mean, like this is now like with very little, it's already starting to look like this, except for the font, right? I mean, like otherwise he has, I don't know if he has his title and subtitle. Yeah, he doesn't have his title and subtitle there yet, but he will. So he's used tab style, and he's used cell borders, and he has gotten that line to where he wanted it to be. And then he now, what has he done here? Oh, now he sets the labels. Okay, so here, he has added a tab style element, and he's added another border here. So you can see now there's a border on top, right? And he's assigned the weight of that border line, and he wants it across all of the column labels. Like, so in other words, it has to be below, like the row that spans the column labels, he wants that line to run across that entire like line. So now he's established his boundaries there, and he's going to go ahead and add his titles. So the calls underscore label is kind of like your calls width, your calls padding, your calls height, or your whatever. Like it can specifically target that aspect of your column. So what he's done here is that he's building on everything, right? So now he's added calls label. And what he did is that you can see how when he says label, it's not the same as name. So he probably doesn't want to call it player because player is probably what came in with the data set. So let's take a quick look at the data. Yeah, so the data set had a column name called player, and he's retained all the column names here, and he probably doesn't want to do that. So what he does now, he assigns labels to that because it's he wants to change the label of that. So you see how he's up. First of all, this is an uppercase, and then yeah, players, player, salary, salary. So he's just made those uppercase. And now he's added a source node. So if you guys recall what a source node is, it basically ties in that entire table. It tells you where all of the contents of that table came from. So he wants to say that it's Thomas Mock, it came from his GitHub source, yada, yada, yada. Then he sets the tab header. So the header is this. You have the title and you have the subtitle here, and here, yeah, I wanted to point out this actually. See how he has used the MD function here. This is just your straight RMD. So Rich has allowed us to either use HTML tags. Oh, so you can actually even use HTML tags and use whatever formatting. So if you know HTML, you can say title is equal to HTML, open your thing, put that in, close that, all of that kind of stuff. Or you can use straight MD. And if you're used to using RMD, you know like how. So these two I think are like bold, and if you have 3 stars, it's italics or something like that. So you can see he's bolded it, right, by using that MD. And this bottom guy is not bolded because of the fact that it's, you know, it's not in any way formatted. So like this is now like other than like whatever he's done here with the color and everything, like you can see that it was really straightforward. So now here's the absolute best part, because I love fonts and I love colors. You can pretty much get the whole Google font family into this. So you can if for those who are not aware of the joy that is the Google font family, it is really something else, and you can download the whole set. So I forget where I can do that. View your selected. Okay, it's not there. It's somewhere here. It's some. You can. I'm drawing a blank right now, but suffice to say, you can actually download all of these fonts, right? You can download all of those fonts, and then you can pull them into either your extra font reader or something. Or what is it called? Extra font. That's what it is. You can pull it into extra font, like you would obviously have it in whatever location that you had those fonts downloaded to, and you can use the entire gamut of fonts available there. So let me just quickly. What is it? Google. Here's another really cool thing that he has provided. He has these info helper functions. And so you can come in here and type, and if you want, let's say you want to see all the palettes available, right? If you type your info_palette here, he will tell you all of the palettes available. So, I mean, look at this. AW Tools, Dichromat, Dutch Master, GGSCI, which we saw earlier. You have the Ghibli package, which is my favorite, and every conceivable package you can think of is here. So like, I mean, like you can just go to town with this. Okay. And then if you go to the info_Google fonts, I mean, like this is like nuts. Like this is insane. You can look at all of your Google fonts, right? Like I'm not even going to click on any of these because we kind of had a, we kind of saw how big that is, but like it gives you a lot of options to, like he has used Freedom Mono and I think Carla for this particular data, and see how it like it's starting to look really so similar to what he pulled in, right? Like, so this was the original from wherever. Let's see, where was that? Yeah, this was the one he was trying to replicate, and like he's just chipped away at it, and then ultimately he ends up with that. And then he saves it. So we did take a look at that. We did the GT save, which didn't work on my machine, but it probably will now because I have it. I restarted my session, so we can actually do that really quickly. GT save. Okay. GT preview. So GT save should be right here. Yeah, I'm gonna run this. So I think it did run. I'm going to go to files, and where is my R-Ladies? R-Ladies Dallas. Okay. So the file we are looking for is this tab_1_ inline HTML. Voila, it's there now. It just got created at 7:04 p.m. So if you click open in web browser, it's basically the table that we just saw. I mean, like this was in like very initially we created this and we hadn't really gone through all our formatting little workouts yet. So it was just like pulling in this exable data set. And so like, it's not the most like whatever highly formatted one, but suffice to say you can have it as a HTML or a PDF or an SVG or one of those things. And then you can just plug it into, wherever you're presenting it. So this is all of his code. It's 7:05. I don't want to like take people away from their evenings, but I will tell you one thing that you should really look into. And I didn't have enough time to review this before this talk because I literally just saw this like this Saturday when I was referring to this. This is so ridiculously cool. It will just blow your mind. He has actually done, so Thomas Mock is like a master of web scraping, but like this was just beyond. Like R-West, of course we know, right? But here he has actually managed to look at the JSON file, and he has it returns like these named lists. So he's made this little video where he shows okay, yeah, here it is. It's ridiculous. Like that guy is so good. Okay, so this is how he, so actually let me show you what that original what he's trying to replicate. It's such a complicated diagram. Does he have it here? Maybe not. I forget if he's actually showed us the final one. It has it's a lot. Oh yeah, this one. Okay, so this is the original article. Okay, it's a 2020 NFL predictions, and they have all of these like cute little pictures and everything, but it's a lot. It's not a straight R-West thing because this is JSON, and I think they actually did provide the data, or so he could have taken the easy way out and just downloaded the data and gone with it, but no, he actually talks about how he scraped it. Okay, and it's really seriously something that you should look at, and how he tackles the API and how he's because he could have just done R-West and like literally got it from there because the data is available, but he talks about, so this is what the data looks like. I mean, this is what the report looks like. And he actually reads the JSON. Okay, so that took a lot of guts. And he has this little video here where he gets into like how he does the cleanup. So I really encourage everyone to look at this because if not for anything else, it's for really, really sophisticated, elegant code. And he just like really breaks it down, so like it becomes very, very doable. So I'm going to stop there, but I've shared both those links, but definitely look up Thomas Mock's blog post, and I will definitely upload this to Git soon. I know the last time Sarika struggled with getting my presentation, but I won't be that bad this time, Sarika, promise.
Yeah, no worries. Is there any quick question that you have for Pavitra? And while people are thinking about that question, I'll just add that Thomas Mock is actually a member of R-Ladies Dallas. Yeah, he's actually attended quite a few of our events and definitely supports us in lots of different ways. Yeah, I'm sure we could even reach out to him and ask him if he'd like to share some information. That's a great idea. Yeah, this is my first time hearing about the GT package as well. It looks like Angelica was also feeling the same way. Rachel, getting a lot of love for you and the material that you shared, and it seems like everybody got a lot out of it. So amazing presentation. Not only did we learn about the primary package that you wanted to talk about, GT tables, but just a lot of best practices and also a lot of other nuggets along the way. So you're very clearly an R scholar, and appreciator of the R different. Well, when I say scholar, I mean you just kind of pay attention to some of the trends and some of the different cool things that are out there and what everybody's doing. So I guess that's what I mean. So I mean that lovingly, not as an insult.
different. So when I see a plot, sometimes it's too much. Like I think I also have like some issues with like being overwhelmed with information. So plots really go the opposite way for me because I get nothing out of them. But a table, like literally you give me any table and I could just stare at it for hours. Like plots just do nothing for me, unfortunately. But I love tables. Yeah, I'm crazy about tables.
So this was, and so that'll do it. I think it looks like we don't have any other questions, so we'll go ahead and wrap it there. But yeah, I know we all learned a lot, and we're all anxious to get to our studio session so we can start to make some tables.
Can I ask a
Thank
quick
you.
question, please, if you don't mind?
Yeah, go ahead.
Yeah. GT is similar to another package, Flex Table. I don't know if you heard about Flex Table, and what do you think when
Right.
you compare it with GT?
So the cool thing about Flex Table is that it's dynamic. So you can like dynamically see snapshots of your data. So that's the difference. Like GT is static, but though I think Rich said that there's going to be dynamic like HTML components to it, like in the next version and subsequent versions. But the Flex Table itself, I think, has dynamic components built into it, if I'm not mistaken. Would that be correct? Or am I confusing it with something else?
No, I don't know, but thank you very much for your answer.
Okay, so yeah, I probably don't know much about Flex Table. I probably know this and GT summary because those are the purposes I use tables for, like either scientific data or whatever. But yeah.
I know we just recently had a talk on Flex dashboards a few weeks ago. So I'm familiar with those, but I haven't heard about Flex tables. So yeah, that would be something I can Google, I guess, and find out more about. But
Yeah.
okay, well, we're gonna go ahead and end it there. Thank you everyone for joining from all over the world. And until next time, yeah, please make sure you visit our website at the R-Ladies Dallas meetup page and learn more about some of the future events. Thank you very much. And thank you to both of our speakers, Pavitra and Praveena,
You
for
bet.
those wonderful presentations. All right, everyone, have a great day.
Good night, you guys.